All right, we're on to video 2 now for lesson 7. We're going to start with what your pulse is, and we're going to be talking about blood pressure a lot in this video. So the pulse, when you're using your wrist or your neck, is really just your arteries expanding and contracting and recoiling every single time your heart beats, particularly when your ventricles push out the blood up into the aorta. And on average, your heart is going to be 70 to 76 beats per minute. It also is going to depend on gender and things like that, and age, which we talk about later. So blood pressure is the pressure that blood exerts against the inner walls of blood vessels. It's this force that helps keep blood circulating continuously between your heartbeat. So you have to have blood pressure. If your blood pressure is really low, you're going to have some major issues. And you also can't have super high blood pressure because you're going to have some major issues. But you need to know that blood pressure really is that kind of force that blood is pushing up against your arteries particularly. So your pressure is going to be highest near your large arteries. So your aorta is going to have the highest pressure because the left ventricle is really just pumping into it. And then your vena cava is going to have your lowest blood pressure. Blood pressure is going to flow continuously from high to low. So it obviously starts out highest at the aorta, and as it makes its way through various arteries, arterioles, capillary beds, venules, and veins, it's going to get lower and lower and lower. And really, that's why veins, remember, have skeletal muscle action and those valves, because if we just relied on blood pressure alone, your venous return wouldn't be enough, meaning how much blood is actually going back into the heart. And you can see blood pressure differences. When you accidentally cut an artery, blood is going to kind of splurt out of it, where if you cut a vein, it kind of is just flowing evenly. And we've all seen videos like, in movies and stuff, when someone gets cut and the blood just kind of splurts everywhere. That would be an artery. So how do we measure blood pressure? It's 2 measurements, and you're going to always hear that when you're at the doctor. They say 2 numbers, and the 2 numbers are systolic and diastolic pressure. So your systolic pressure, or systole, sometimes people call it, is the pressure of your arteries at peak ventricular contraction. And then diastolic pressure is going to be when the ventricles are relaxing and the atria are contracting. Okay, so here is what it looks like. We've all had this happen to us before, where we've been cuffed and we get our blood pressure measured, and they usually say 120/80. That's kind of seems to be normal. The 120 is your systolic pressure, and then the bottom number is your dystole or diastolic number. And it's always measured in millimeters of mercury. And what does that mean? Well, next time you get your blood pressure taken, look up against the wall where they're reading it. That tube that they're reading is filled with mercury. So that's why they're reading it. And it's really actually easy to measure. And if you go to med school or you go to medical assistant school, you're going to have to learn this oscillatory method. And next time you get your blood pressure taken, watch where it's on the wall where the tube is. And what happens is the person taking your blood pressure will really, really pump it up really hard. It squeezes around your arm. And once they let it go, it starts to drop. And then you're going to see this little tick in it where it kind of jumps up for a second. That's going to be that top number. And then again, it will tick, and that will be your bottom number. So that's how they measure it. So next time you're getting that done, take a look, and it's really actually easy to measure. So we're going to talk about blood pressure and how it can either go higher or lower. First, we need to talk about peripheral resistance, and this is the amount of friction that the blood encounters as it flows through blood vessels. And this is going to be affected by many, 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 many different things. For example, when we relate it to cardiac output, for example, if you have a high cardiac output, then your blood pressure is going to be higher. Okay, neural factors. Sympathetic nervous system, fight or flight. We're going to vasoconstrict. When you narrow your blood vessels, it's going to increase your blood pressure. Anytime you are in that fight or flight response, we're going to increase blood pressure because we want to have more available to certain areas. Renal factors. This is actually really important because if your blood pressure is too high or too low, we're going to be able to excrete more water as urine, which is going to lower your blood pressure, or we're going to be able to actually reabsorb water back into the bloodstream, which can increase it. So if our blood pressure is too high, we want to flush out more as urine, and it will decrease. Renin, remember, can be released, which is going to cause aldosterone to be released, which can then absorb sodium and water to also increase blood pressure if it's too low. Temperature. If it is very cold outside, you actually constrict your blood pressure or your blood vessels by your skin because we want to keep the blood more internally. And if it's hot out, your blood vessels are going to dilate and it's going to try to release heat. And you've all seen that before when you're exercising or playing sports. We all have that one friend who really gets red in the face when they're exercising. And it's for this reason. All the blood vessels close to their skin are really dilating, and it's causing their skin to be that flush color because they're just releasing heat. So, we see that obviously more in fair people. Chemicals, anytime you're going to release epinephrine, it's going to increase blood pressure. Once again, fight or flight, adrenaline. Nicotine is actually going to increase blood pressure. Alcohol and histamine is going to decrease blood pressure. And then diets low in salt, fat, and cholesterol will help to prevent high blood pressure and heart attack. Remember, that's really important for heart health. If you want to decrease your risk of high blood pressure, decrease your risk of an myocardial infarction with those coronary arteries, you want to have a healthy diet and keep that throughout your entire life. I know right now it's really easy to go to McDonald's and get a double cheeseburger, but eventually you're not going to be able to do that and live a healthy life. So this is a really good chart here to come back to and study if you're looking at all the different things that are going to increase or decrease blood pressure. So anytime, for example, we have an increased heart rate or an increased cardiac output, we're going to have increased blood pressure. Chemicals like nicotine are going to increase blood pressure. Anytime vasoconstriction occurs, which is basically narrowing the blood vessels, we're going to have increased blood pressure. All right, so hypotension, this is low blood pressure. A lot of times we're not really concerned with low blood pressure because it usually just means that you're really healthy. But sometimes if your blood pressure gets too low, you can go into what's called circulatory shock. And this can be deadly, first of all, if you don't get help for it. And this is something that's not caused by just being healthy. This is some sort of disorder going on. Hypertension is high blood pressure. Hypertension is where you're at 140 over 90 all the time. Not just when you're exercising, not just when you're in fight or flight. This is when you're just relaxing at home. You're very high. And environmental and genetic factors are what's going to do it. Unfortunately, sometimes you can be a very healthy person and still have high blood pressure just because it's in your family genes. All right, the last thing we really talk about is capillary exchange. So we know that capillaries are where oxygen and nutrients are dumped off, carbon dioxide and waste is picked up to go back into the bloodstream so we can remove it. But it's important to know how this happens. And really, we're just using simple diffusion for this to occur, which means that it's not going to use any energy. It's going to be a passive transport. We're going to move from an area of low to high concentration. So as oxygen is moving through the capillary bed, you're going to have more oxygen in the capillary than in the tissue. So naturally, it's going to want to go to where there's a lot to where there's a little. So it goes from an area of where there's not a lot where there's a lot to a little. And most capillaries also have intracellular clefts. And intracellular clefts allow a little bit larger items to be able to kind of go through the capillaries. So like some waste products or maybe some small ions. And then if it's a large item that can't go through a membrane, we have to use endo and exocytosis, which is a type of transport that we create a vesicle out of membranes and move it to and from the tissues and the capillaries. So this is really important. It's really important to know that oxygen goes into the tissues and carbon dioxide leaves. Carbon dioxide is your waste product. And the reason carbon dioxide is a waste product is because you're using it to make energy. So the things you need to make energy or ATP energy is glucose and oxygen. When you're done manipulating the glucose and oxygen and creating ATP, you're left with carbon dioxide. That's your waste. So we have to get it out. So oxygen moves in and carbon dioxide moves out. And then over here, this is kind of a close-up. It's kind of cool. It shows you those intracellular clefts that allow items to kind of move in and out of the capillary. All right, that's it. We made it. So thank you for watching. Make sure your note guide is filled in completely. And if you need to go back and watch these videos, please do. Now make sure you complete all your assignments for this lesson.